We just learned about async and enumerables and all kinds of crazy mind-blowing stuff. And we're going to switch gears a bit, and we're going to be talking to Stefano. And Stefano has a really cool talk where he's going to be, this is some more kind of visual stuff here. Wait, I actually have even a banner that I'm supposed to pop up on here. Oh, it's custom vision, right?
It is custom vision, yes.
I'm excited to hear all about it. So I don't see your screen shared anymore. When you're ready to share that, we can pop that back up.
Sure thing. Coming through.
There it is. I'm going to add your screen and I'm going to disappear.
Okay. Thanks, John. And hello, everybody. Welcome to Bring Intelligence to the Edge with Custom Vision. I'm actually going to justify why custom vision with a few examples which I hope you enjoy. My name is Stefano Tempesta. I'm a CTO at Connecting Software, and I happen to be also a Microsoft Regional Director based in Melbourne in Australia. So custom vision, in general, computer vision, that is all part of a broad set of services called cognitive services that you can run in the Azure. You don't have to be a specialist in artificial intelligence or machine learning for doing cognitive services, for consuming the services, because they all run in the cloud as a managed services, exposed as a REST API. And I will show you a few examples, obviously in .NET. Today is all about .NET, clearly, and not as in a no-code solution using logic apps as well. Just to show you how powerful are these cognitive services. Exposed as an API, no need to know any AI technology and or Python or R or all these fancy programming languages that data scientists use. All you have to do is just focus on consuming the specific service. Now, computer vision, custom vision are part of a broader set of services which go under the vision category. Cognitive services also have speech, language, knowledge, and search. If I had the time, I would speak about all of them, but we only have less than half an hour, so let's focus on vision. And when speaking about vision, we are really looking into analyzing content, detecting objects inside content, detecting faces and identifying faces. Let me start from computer vision so you can appreciate the difference with custom vision. There is a difference and you will appreciate in a moment. Let me go through a use case, which is I have a lot of pictures that I take every time with my smartphone, and I'm sure you do as well. And then they go uploaded automatically in OneDrive, which is another fantastic feature. So I have over 10,000 of those pictures in there, which are categorized in a chronological order by date. That's also a great feature in OneDrive. Thank you very much. But what I sometimes miss is the possibility to go and find a specific picture that has a car in it, or has a beautiful tropical island in it, or have some family and friends that are in there, and I want to find very clearly. Yeah, sometimes, I'm getting old. I don't remember when I took that picture, so I have to go and scroll through the long list of those images that I have in OneDrive. It takes a bit of time. So what I came up with is a use case of computer vision, of detecting, analyzing images that I take in OneDrive, detecting or classifying these images, what they are about, into categories, and then automatically, as they get uploaded into a folder, moved into subfolders after a specific category, that after a specific tag. The computer vision does this for me. So I have my little assistant that is powered by artificial intelligence and does all this classification for me. All right, so how that looks like. Now, let me start showing this into OneDrive. This is actually OneDrive for Business. So I have a folder here called Images, which is empty at the moment. And then I'm going to go and show you a few nice pictures that I have in here. I have a collection of stock images that I typically use for testing these cognitive services, including custom vision, content moderation, and so on. We'll focus on custom vision in a moment. What I'm going to do is, first of all, I need to activate my flow. So spare with me a second, and then obviously I will show that flow, how that looks like. So I'm going into, and actually I can show you what I'm doing. I'm in the Azure portal. I open my Logic apps. I'm enabling my flow and run this flow. So then we'll go into the details of the flow. So I'll park this for a moment. So the flow is running and is actually now polling this folder for files that I upload. So I go here into my stock images. How about some cars? Pick one. Any preference? The yellow one, the red one, the white one? Okay, let's go and pick this one. All right, I'm gonna put and upload my car in here. And you can see just a generic car. Now, whatever the image is. And sometimes when you take picture from your smartphone, it just have a timestamp on it. So here is the flow that is running. When a file is created in OneDrive, analyze the image, do a little bit of magic in here, which I'm gonna show you in a moment. All done. So what happened? Well, what happened is that magically or automagically, that file moved into a folder named after something that we'll try to understand in a moment. And the image is obviously in there. Okay. I'm not paid by Porsche to do this demo for them, this demonstration. All right, let's pick another one, shall we? So instead of a car now, just to give you a different flavor, how about just generic flowers? Nope, not this one, but this one here. So I'll take this beautiful bouquet of roses. So I'm going to upload this, and hopefully that flow is still running, and it checks for update from time to time. So it may take it's not real time, obviously, but it is running here. All the flow is completed, and here we go. Picture's gone, plant, flower, and that's my picture, which has been automatically classified. So what is this trans_car, plant_flower? These are categories that have been identified by computer vision. And the way it works, basically, and this is a super simple flow, I'm sure that you can make it even more sophisticated. So I'm in the Azure portal. I built a Logic apps. The trigger is when a file is created in this folder, in the image folder. You can see here the image folder. Check every 10 seconds, so it's actually very frequent. And then analyze an image. This analyze image, just going to show you what actually is a computer vision. So just search for computer vision in there, and it should come out in a moment. Is this one? I believe there is another one. I need to check what is that, and then do the analyze image. When you do the analyze image, which is this action that I already have on the content of the file that has been uploaded in the previous step, then I'm initializing a variable to just say the file has not been created. This is my exit loop in this for each, because multiple categories can be detected. You see, there are multiple categories that are detected by the analyze image computer vision task. And for each category, I'll check if this one is not really visible, unfortunately, but you may appreciate that there is a score in there. I'll check the confidence score that is greater than 0.8. Each category identified by computer vision comes with a confidence score. And this confidence score is an expression between 0 and 1, is a number between 0 and 1, where the closer to 1, the more confident is that the prediction has been identified correct for that specific category. Because sometimes, you can get some images that are a bit confusing and is not the one, and is not easy to identify that category. So if the confidence is 0.8, this is completely arbitrary. I decide to put 0.8. It's my threshold. If you want higher accuracy, obviously you can increase this level. So if it is true, what is going to happen is that I'm moving that file into a subfolder of images called after the category name with the same file name. If not, I'm going to create a log file with the same file name .log, and inside I just write the category name equals the confidence score. I want to find out what is the confidence score, which is going to be less than 0.8, just in case something happens. And because the automatic analysis is not good enough, or the confidence is not good enough, then I don't want to automatically move the file, otherwise I will lose it, who knows what. And then this runs, the file has been created, it's true, so it runs until the file is created, okay? So that's the way our flow works, super easy. Now, let's go and do another test. And I want to ask you, all of you guys watching this, so if I pick this one here, what do you think it is? Would you classify this as a car, or would you classify it as a flower? And I've been doing this testing in front of people when we used to do face-to-face events, asking for a raise of hand, and it was a split 50-50 most of the times. Some people would say car, some people would say flower. What do you think it is? What do you think the AI will say? All right, so let's find out. So I'm here and upload. Oops, where is my folder? Here we go. Upload in here. Okay. In case you're wondering why I have all these things here, because I also enjoy play with face detection, with content moderation. So I have some stock images to try all my cognitive services, okay? Just in case you're wondering. I don't go around and take pictures of Prince Harry. All right then. Oh gosh, what happened here? My picture didn't move. And it didn't move, and it actually created a log file. Because if I go and see inside, this is unclear. 64% that is a plant, not even a car. All right then, so something is happening here. Is the computer vision not good enough? Is not accurate enough? Well, the answer is that it is accurate. But the problem is that with this kind of images, let me show that again one more time here. This sort of images here, the model that the fantastic engineers at Microsoft have used to train computer vision with thousands and thousands of samples that have been labeled doesn't account for this hybrid scenario. And just in case you were wondering, I'm not paid by Joe Maloney in London for any sort of advertisement here. Okay, so we need a better way of doing it. And you're lucky because a better way does exist, and it is called custom vision. So custom vision is a computer vision, but with your own model that you can train with your own data set. So computer vision contains over 10,000 of classified images that the fantastic guys at Microsoft product group have classified. And it takes some time to classify image by image, but they can't classify everything in the world. And sometimes you may have a need to identify something that is very, very peculiar. So custom vision, which leverage the same engine from a machine learning perspective of computer vision, but you have to provide your own images. So if you want to use custom vision, what you have to do is go to this fantastic website, customvision.ai. Upload your own images, train, and evaluate. At the end, you get a REST API, so a web service hosted in the Azure cloud which is your API for the custom vision, custom vision that has been trained on your model. So you get your unique web service just for you, your unique REST API just for you. Okay, so let's go and see custom vision in action. Custom vision, not in this browser, but in this other one. Okay, here we go, another tab, customvision.ai. Right, I'm automatically signed in with my Azure account because you see I have Azure here in the same tab. But obviously, if you have the possibility, if you sign in for the first time, you need to sign in with your Azure account also in customvision.ai. I have a couple of projects here. For example, another one is skin condition detection. That is something that computer vision cannot do. Computer vision is able to identify a face, identify eyes, nose, mouth, but is not able to identify concern or conditions of your skin simply because it's not been trained for these very niche applications. And now, staying on topic for car and flowers, I already have the project created. Just in case we run out of time, I want to create a brand new directory with you and show you how easy it is to create a project in custom vision. So how about we create a project and we call it classify funny cars with flowers. Okay, and maybe we'll work also on the spelling here. Okay, something like that. Give a description. Now connect to an API or actually an Azure resource, a custom visual resource that has been deployed in Azure. I already have. I will show you in a moment how to do that. And then you decide the project type. Is it a classification problem or an object detection problem? Obviously, if you don't know what it is, just ask for help. But image classification basically looks at the entire image and say, hey, what is inside that picture? There is a car, there is a flower. But object detection looks at the specific object, detect the rectangles where the objects are. Think about for a moment, take a step back if you're sitting at your desk and look at your desk. Take a picture and describe what is it in that picture. It's a desk. That is classification. And then I tell you, hey, look better. What is on your desk? Ah, you mean I have a laptop, I have a second screen, I have a microphone, I have a mouse, I have a bottle of water, and so on. Then that is object detection inside the same picture. Okay, then you can also do a multi-label or multi-class. So basically assign multiple tags for each image or just a single tag for the entire class. And then there are some domains. These are slightly specialization of custom vision that can help the engine to be focused more on generic, panoramic, food, and or retail. The compact version is the hint to the edge in the title of this session, because is edge not is in the Edge browser, but edge in your device that runs on mobile IoT. So custom vision can train a model, and then you can download the model and run it completely offline inside your iOS, Android, Arduino device, whatever the edge is for you, which means that you don't even have to be connected. You don't need a real-time connection to internet to make your computer vision work. It works completely offline. Okay, so for now, let's go for classification, single tag, general domain, and create a new project. Oh, no, I can create more than 2 projects on the free edition. That's okay. We'll work on the existing one. So when you open an existing, or when you create a new project, you will basically start uploading images. You need at least 5 images for each category. So I have uploaded 5 images and tagged them. So basically you add an image. When you add an image, pick the image and give a tag, a label. So you're labeling images, 5 cars. You see, I have 5 cars in here. And then you add the other ones, flowers. Okay, so upload the images and flowers. And then I need something which I call it in momentum of improvisation, a flower car, whatever that is. I couldn't find out a better name in English. Flower car, okay? So a mix of it. As you can see, there is Joe Maloney in there. So this is Joe Maloney, okay? Joe Maloney is here, but is not in the data set that I'm using for training, because I want to test Joe Maloney. I want to recognize Joe Maloney, but obviously I cannot use it for training, otherwise it will obviously be recognized in there. So then I run the training, which I already done, and I'm super lucky in this case. I'm getting 100% precision and recall and average performance, and this is because all these images that I'm using for training are clearly flowers, cars, and these mixed flower cars. So the distinguish of the object inside is quite obvious. So I'm getting the best performance ever. You may not be that lucky if you have a variety of images and a large number as well. Obviously, with just a few images, 5 images each, is enough to get the training done. But it will probably not account for all the different conditions of light and different type of flowers in the world, different type of cars in the world, and so on. But it's good enough. It's good enough. So then we can do a quick test, shall we? So then I can browse for Joe Maloney one more time. Here we go. Open. And let's see if you're lucky. Cross fingers. What happens? Yay! Joe Maloney has been identified 99.9% of confidence. That is a flower car. Not a car, not a flower car. So my custom vision model worked perfectly in identifying this fictitious category that I have created, which cannot be contemplated by computer vision, but it is actually inside custom vision. Job done. Now, before we close and open for a few questions, what I want to show you is going in the Azure portal, how to start with computer vision and with custom vision. So all you have to do is create a resource, just type computer vision, okay, and you get your computer vision resource in here. Create, choose who is paying for it, choose your resource group, choose your region, multiple regions are available, give it a name, unique name, and a pricing tier. Incredibly free for 20 calls per minute, up to 5,000 per month, or which plenty for testing purposes, or if you're looking for production, obviously, 10 calls per second. If you look at the pricing details, you'll be amazed. A fraction of $1 per 1,000 of calls. So it costs really nothing. You can scale it to millions and still paying not significant amount of money, which is fantastic. Now, instead of creating yet another one, I'm going to open the one that I already have. And all you need to do, basically, is grab a key and an endpoint, and then start with C#, Python, Java, with this quick start. Now, this is a .NET conference, so what we're going to do is we do it in .NET. So because in .NET we are lucky to have a NuGet that we can use as a wrapper around this API. It is a REST API at the end. We don't need to do an HTTP client request at all. We just go and use this NuGet package. Microsoft.azure.cognitive services.visual.computer vision. Long name, but quite clear what it does. Doesn't it? Which means that you get these 2 namespaces. Computer vision with the interface and the client object and the models. So all you have to do basically, and you can see, you can follow me, it's very, very simple. Create an object of computer vision client, which is in this namespace with a key and an endpoint that you have obtained from the Azure portal. And then just one single line of code on the vision object do an analyze image in stream async. Every call to these REST APIs, cognitive services in general, are asynchronous, so you will always be using the async await pattern. Pass the image as a stream, and then a collection of, or a list of features that you want to analyze. So you can analyze categories, description, face, tags, colors, brands, object, and so on. Is fantastic. And then if I run this very quickly, just as a last minute example, this is in the context of a chatbot. So there is a chatbot here, but forget the chatbot for a moment. I'll go here, take this card this time, go in here, upload, and now this is done. This is doing some images analysis, and they say we get the categories that we have seen before, a description in plain language, a blue car on a beach. How fantastic is that? And multiple tags. Okay, it didn't recognize the brand for some reason, probably because it's not that visible, but sometimes it works. It's able to recognize the brand. I think with this one is more obvious. So I upload the Volkswagen Beetle, and indeed it comes out as a yellow car parked on a road and the brand itself. And the last sample I want to show you is that it also recognizes VIPs. So if I pick this gentleman here, it will even say that he is Barack Obama smiling in front of a flag. How cool is that? It even recognizes people. I tried with myself, it didn't recognize me. Shame on computer vision. I need to work on my VIP status. All right, then. That's it. Thanks for joining. Let me know if there are any questions. Happy to share this quick experience at .NET Conf. Enjoy .NET 5.
Yeah, that was great. We did have some questions. So one that came in, I think it flashed on the screen pretty quickly, but is there a Java API for this?
Java, Python, and C#. There is a quick start guide. But look, at the end, is a REST API. You can use any programming language. You can do it in JavaScript, TypeScript, Angular, React, Vue.js, any programming language or framework that can do an HTTP client request. Job done.
That's great. That's great. Let me see. There's a question about training offline. Is it possible to train a custom model offline?
So no, the training is online in customvision.ai site, but then you download the model to use it offline. So the training still happens online because you don't have access to the source code of the machine learning service that is used for training. That is all done in the cloud. But then you get a trained model which you can download and use in your mobile app.
So the training is online, but then you can evaluate offline.
Correct.
Okay. Correct. Another question: is there an API for an entry point for the workflow validation? I'm not sure exactly what this question's asking. You showed the API, right? I mean, the API allows you to. So
that's Custom Vision as an API that we can use as an entry point for its workflow validation. Probably I get what you mean. Yes. So Custom Vision exposes 2 endpoints. One for training and one for evaluation. So if with workflow or validation, you means the evaluation part of it, so the testing, then yes. So there are 2 entry points or 2 endpoints in this API. One is for training and one is for evaluation. And there is a good reason, because you may be building 2 separate apps. So you need also a different key for these 2 endpoints. One app may be doing the training part of it, or and the other one can do the evaluation, so the consumption of the API. So when I said before that you have to do the training online, it still applies, but there is an API. So you don't have to go into customvision.ai to do your training. You can batch it in PowerShell, for example, with anything that can call this API. But there are 2 APIs, one for training and one for evaluation.
Great. Okay, one last question. And this one really just reminded me, you showed the examples of using and training and calibrating. Is there a way to give negative examples? Can I train it? This thing is not a car. You keep thinking it's a car, but it's actually a flower or whatever. Is there a way to give that negative training?
Yeah, so well, sort of, right? You have the possibility to add multiple tags. So then you have to choose the multi-tagging option. And then tagging is always positive, as in you add a tag. So you don't remove a tag, because the image, when you start tagging or labeling, is just an image. And then you go and say, this is a car, this is red, and this, you can start assigning different tags for it. So, for example, brand recognition is done with a multi-tagging. So it tags a car that is a Volkswagen. I'm not paid by a Volkswagen, but is yellow and is Beetle. So then multi-tagging add this capacity, but you cannot say is not something. Otherwise, it's not anything else, right?
Yeah. Okay, that makes sense. Great. That was amazing. That was a really cool overview. We give you a very short amount of time and you blew our minds. A lot of really positive comments in the chat. So thanks a bunch, Stefano.